Welcome to 6.2, where we are going to be talking about graphs. I can speak, okay? So let's remember a little bit. After I spent like a bajillion hours after the last video playing with my cat, hopefully he leaves me alone now. Not that I want him to. But remember, if you have y equals a times b to the x, a is the initial value. B is the growth rate. Right? So if you have an exponential function, if it's growth, it'll look like this. Right? Where this is our a value, that y-intercept, that initial value. Maybe it's doubling every time you go to the right. Maybe it's halving every time you go to the left. Or if it's decay, right? If a is smaller than 1, so if b is smaller than 1, if b is like a half or a third or 2/3 or something like that, it looks like this. It's decaying over time. This is still a, right? The initial value is still a, whether it's growth or decay. And again, if you ever forget what these things are looking like, you can just plug in points and see, or you can check your answer on Desmos, okay? So in general, this is what's happening. We can say a couple things about this, all right? Right? For example, the y-intercept, whether it's growth or decay, y-intercept is always that a value, okay? That's why it's there, okay? And b is the growth or the decay rate. We can also talk about domain and range. So again, domain is all the x values. Well, we have all the x values, right? We can go as far to the left as we want. We can go as far to the right as we want. Our domain's negative infinity to positive infinity. The range isn't though, because no matter how far we decay, we never actually have 0. We get very, 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 very close to 0, but we never actually hit it. So the smallest we're ever going to get, whether we have growth or decay, is positive infinity. The smallest we can get is 0. The biggest we can get is positive infinity, excuse me. And there's what we call an asymptote on the line y is equal to 0. This is the x-axis. And that means that whether we're growing or decaying, on one side, we're going to get really, really close to that x-axis, never actually touch it. Okay? So for anything of this form, this is what we have. And again, not everything's going to be in this form, but it's a good place to start. Okay? In standard form, we have this. So let's look at some examples and see what we've got, see what we're dealing with. All right, we're going to start with some examples that are the first couple of homework problems that you have. So let's say we're looking at the graph of f of x equals 1/2 to the negative x, so it's already not in standard form, right? We could use that negative exponent. This is the same as 2 to the x, growth rate of 2, y-intercept of positive 1, the number out in front. But anyway, the graph of this function f is reflected, oh yeah, function transformations, is reflected about the y-axis, compressed vertically by 1/5 and shifted down 2 units. So a lot is going on here. Reflected about the y-axis, that's left to right. Compressed vertically, getting shrunk. And then the whole thing is getting shifted down 2 units. So part A is going to ask, what is the new equation? We have to incorporate all that stuff. So reflecting about the y-axis, it's a horizontal reflection. Horizontal change means on the inside by the x. So in this case, inside means the exponent. It's always where the x is when we say inside. All right, so it's getting reflected. So let's call it g of x. Still going to have that 1/2, but it's getting reflected about the y-axis, which means we put a negative by the x. Well, there already was a negative by the x, so 2 negatives by the x is going to make that x positive. Getting compressed vertically by 1/5. Vertical change is going to be on the outside. Compress means multiplied by 1/5. Multiplied by 1/5 on the outside of everything, that's that vertical compression. All right. And then it's also getting shifted down 2 units, so that's subtracted 2 on the outside as well. So this is our new function. All right. And we have some questions that we can ask about it. All right. Part B is going to be, can I fit this? I cannot fit this on the page, but what I can do, get a new page and do some modern problem solving. Maybe. All right. So what we've got, and now I'm going to ask you a part B. Find the domain, the range, the y-intercept, and the asymptote. And we'll see if we're right. So, domain. Remember, domain of any exponential function is negative infinity to positive infinity. Our domain here is still negative infinity, positive infinity. The range, if it's in standard form, the range is going to be 0 to infinity. Okay, if it looks like this in standard form, 0 to infinity. We don't have standard form here though, right? It's almost standard form, a times b to the x, but the whole thing is getting shifted down 2 units. All the y values are getting down 2 units. Range is y value, so we need to move all of this stuff down. Move this down, 0 down 2 units, now -2. Infinity down 2 units, that's still infinity. Okay. And for the asymptote, again, normally the asymptote is at y equals 0. But if we're moving everything down 2 units, it's not at 0 anymore. It's at y equals 0. Move down, it'll be y equals -2. Okay. So just kind of look at what is all of this stuff for something in standard form, and then what is it for our situation? Okay. And again, we're asked the y-intercept. Normally the y-intercept is that a value right here. The a value is 1/2, but we're getting moved down to. So it's going to be 1/5 is the a value. 1/2 is the decay rate. 1/5 is our normal starting point, but we're getting moved down to. That'll be 1/5 minus 2. All right, that's going to be -9/5 or -1.8. And again, if you forget some of these rules, you can plug in, right? The y-intercept is when x is equal to 0. You can plug in x equals 0 here and see what you get. All right. For a lot of this other stuff, again, something that's really important if you're struggling with these problems, something that's really important is that the minimum or maximum value of the range is always going to be the same as the asymptote. This 2 will always be the same, that -2. Anyway, that's our answer here. Let's check if we're right. Okay? Let's graph this new equation. So if we're graphing this, let's go to dark mode. We're graphing this, we have g of x is equal to 1/5 times 1/2 raised to the x power minus 2. The domain here, all the x values. Well, we have any x value we want, all real numbers. Look at that b value. That b value is 1/2. That means it should be decay. And again, you can see that we are decaying over time. The range, we said the y values, it gets really close to -2. Look at the y value on the y coordinate that I'm hovering over. It's really close to -2, but it never actually hits it. Okay, so the smallest it can get is almost -2. And the biggest y value goes off to infinity. Right? We had that right here for our range. The asymptote we said was at y equals -2. Well, what does that look like? Y equals -2. Yeah, that orange thing, it gets really close to the orange thing, but it's never actually going to touch it. Kind of looks like it touches it on the website, but it doesn't, right? You could zoom in really close. Really close. Oh my word, this is making my eyes do weird things. You see, they're not actually touching it. It's really close. We had to zoom in so far. But you can see that it's never actually hitting that dashed line. You can't even see anything. Nice. I have the wrong scene. All right. I think I must have clicked something weird. Again, it looks really close, but as we zoomed in, we saw that it wasn't close at all. But again, that is the y. That is the asymptote right there. And the y-intercept, we said the y-intercept was negative 1.8. Check. Yep, there it is. 0, negative 1.8. Great. So we checked our answers. We know we're pretty okay. All right. Let's do some more stuff in this section. All right. I'll even make sure to be on the wrong scene. Right scene this time. I'm not on the right scene. Huh. Right? Woo! Maybe one of those days, I guess. Look at some more stuff. Example 2. Evaluate the following. We've already done this sort of thing. This was in 6.1 as well. But just in case, since it is included here, I want to talk about it. And I want you to evaluate f of x is equal to 4 times 2 to the x minus 1 minus 2 for the following function values. When x is equal to 2. You just plug in 2 here and follow order of operations. Just be very, very careful. F of 2 is going to be 4 times 2 to the 2 minus 1. 2 minus 1 is 1. Minus 2. So this is 2. We're going to get 8 minus 2 is 6. When x is equal to 1, we do something very similar. We get f of 1 equal to 4 times 2 to the 1 minus 1 is 0 minus 2. Any number to the 0th power is 1. This guy right here becomes a 1. 4 times 1 is 4, minus 2 is 2. And you can use your calculator for all of these as well. You don't have to do these by hand like I'm doing them. I want to show you. Okay, if x is equal to 0, right? We're going to get f of 0 is equal to 4 times 2 to the x minus 1. If x is 0, 0 minus 1. Remember, negative exponent means reciprocal. It becomes 4 times 1/2 minus 2. This will become 2 minus 2, which is 0. All right, so watch out for these ones, especially if you have a negative exponent. Make sure you're typing them in correctly if you're using a calculator. Double check them by hand would be a good idea. If x is negative 1, again, we'll get f of negative 1 is equal to 4 times 2 to the negative 1 minus 1. That's negative 2 minus 2. And again, 2 to the negative 2 power is 1 over 2 squared, which is 4. Minus 2. Negative exponent means reciprocal. That'll give us negative 1. Right? And that's how we evaluate these exponential functions. This is very useful when graphing, because when graphing, we want to plug in a bunch of points and see what the y values are. You have to plug in a bunch of points and get these y values like so. All right. You can use a calculator. You can do it by hand. Best to do it both ways and make sure you get the same answer. And if you don't get the same answer, you can re-examine and see which one is wrong. Right? But that's the idea here. All right, example 3 is going to be graph y is equal to negative 2 to the x plus 1, and find the y-intercept, find the domain, the range, and the asymptote. So earlier on, right, I said, you don't even need to graph this to know all these things. Look at what something's going to look in standard form, and then use function transformations. And that works. But hypothetically, let's say that you're not 100% confident with that, hypothetically. If you want to find the y-intercept, domain, range, and asymptote, you can just graph it. Okay? Make sure you plug in a lot of points, though. Okay? Let's go 5 in each x direction. Let's maybe go 10 or something in a y direction. All right, if you're counting right here manually, it can be helpful to make bigger slashes for the 5 mark and the 10 mark. Okay. So we need to graph this. You're just going to make a table of your x's and your y's. A lot of times it's easiest to start with 0, then go up and go down. Right? So if x is equal to 0, you plug in 0 into your calculator here. You get negative 2 to the 0th power plus 1. Now be very careful here. The negative is out in front. You want to rewrite this function with parentheses like here. That can be a good idea. The negative doesn't happen until after the exponent. It's like multiplication. Multiplication doesn't happen until after exponents. Watch out here. The 2 to the 0 is 1. You'll get negative 1 plus 1, which is 0. At that point. When x is 1, type it into a calculator. Negative 2 to the first power plus 1. If you type that into your calculator, you should get negative 1. If x is 2, you should get negative 2 squared plus 1, negative 4 plus 1, negative 3. 2 comma negative 3. If x is 3, you get negative 2 cubed plus 1, negative 8 plus 1, negative 7. So that is pretty helpful for positive values of x. Negative values of x are going to be helpful as well. Negative 2 to the negative 1 plus 1, type that into your calculator, you're going to get positive 1/2. We'll plug that in. You plug in negative 2, you get negative 2 to the negative 2 plus 1. Type that into your calculator, you're going to get 3/4. If you type in something else, you're going to get you're going to get 7/8. And then 15/16. You can see it's going to get leveling off really quick if you do. So, to finish the graph, just connect all the points like so. Now we need to find the y-intercept, the domain, the range, and the asymptote. So what we're going to do here is again go onto this second page, like so. Look at them one at a time. The y-intercept is where it hits the y-axis. Where it hits the y-axis when x is equal to 0. The y-intercept is when x equals 0, so you just look over here. Oh, when x is equal to 0, y is equal to 0. So that's our y-intercept right here. Y-intercept is when x is 0. So when x is 0, y is 0. Y-intercept is right there. Domain of any exponential function ever is always all real numbers, negative infinity to positive infinity. That will always be your domain. Range is a little more complicated. Range is y values. The lowest y value we can possibly get is negative infinity. It does go off to the depths. The biggest y value, well, as we go to the left, we get closer and closer to 1, but we never actually hit it. It's going to be the maximum. We never touch it, so it's going to be a parenthesis. We get really, really close. And this video is way longer than I thought it was going to be. And the asymptote is always at the edge of the range. Okay? The asymptote, as soon as you know your range, you know your asymptote here. It's going to be y is equal to positive 1. All right. So that's answering everything for that question. And goodness gracious, that was a long video. Hopefully you paused, took a break, got a drink of water, did some math problems just for fun, and then came back and split it up. In the future, that is a good idea to do for long videos. But anyway, let me know if you have questions. This is tricky material. The other 2 videos for this section will be much shorter though. Okay? I just didn't split it up very well for this section.